Hey, good afternoon. I'm Ruben Dominguez. And I have been given the task of getting this very large thermal vacuum chamber up and running in the ARB building. Okay, so we are currently actually done with the entire building. There's a few little punch list items that are left to do, but the third floor has already moved in. That's where they have the CubeSat and they have some other third floor labs. Ewing Douglas's satellites work is done in there, okay? But I'm not gonna talk about the third floor. I'm mostly gonna talk about the floor, first floor, second floor, and the fourth floor that have something to do in common with a thermal vacuum chamber, okay? So it's still ongoing work, and we want to commission this thing somewhere in November, December, so that we're ready for the first instrument sometime in January of 2024. So our chamber has two basic requirements. The first one is for ballooning. We want to simulate a balloon payload taking off from Antarctica or anywhere else at ground level and simulating the atmospheric conditions as they go up to elevation about 120,000 feet. And there we have to take into case the vacuum pressure and the temperature and the time. So we got together with some vacuum pump manufacturers, and we got Pfeiffer Vacuum that can do this through a variable frequency drive. And they can actually program the speed and the temperatures to get this whole thing to simulate a balloon going up into the upper atmosphere. The second phase, the second requirement, I should say, it was just for space-based. And that was just to let the vacuum chamber go as cold as possible and as high as vacuum as we can get. So here's just some equipment. And I put this thing here because actually we can actually do more than just a vacuum for the payloads and for the space. We can also do some optical testing that I've been talking with Daewoo. But the other one that had just come up is something from Biosphere 2 with Trent Tresh. He wants to put people inside the chamber with spacesuits. That's something that just came up. So I put this down so they can have more or less an idea of what the vacuum chamber can do with the pumps. So here's what the first floor looks like. We have payloads, Bay 1 and Bay 2, where you can come in, put all your instrument in there and build it up. And you can then come in and put it into the airlock and go into the thermal vacuum chamber. The other thing you can do is up to the left, you see we have a shaker table. We have a vibration table that's about 10 foot square, 10 by 10. And it has shaking in all three directions, X, Y, and Z. You can do each one individually or all three at the same time. We also have the anechoic chamber. So you can put your instrument in there and test your antennas and put a receiver and see if it's, and tune it. So after all that, you can also put in the vacuum chamber. We have separate clean rooms also. So you can also do individual instruments, the smaller. Maybe they don't have to go into the thermal vacuum chamber, but there is a clean room in there. And they can go into the high bay. So here's the second floor. Second floor has areas so that your team can set up and do their work while you're doing the thermal vacuum chamber testing. There is a test instrument control room. You can actually monitor your instrument while it's inside the thermal vacuum chamber. On the other part, this is up at the upper right corner, you see a mission control area. Once you put your instrument up in space or at low Earth orbit or the balloons at 120,000, you can actually monitor them from this area, mission control area. And we already have 3 instruments that are going in there. 2 of them this year and I think 1 next year. On the 4th floor, which is the roof, we have a very large antenna platform. It's a 20-foot by 50-foot area. It's raised off the roof, and we are going to have some antennas up there that you can place, and you can do either you're communicating with your instrument, okay? And there's also a satellite equipment control room, so you can actually monitor your room from there, okay? You can also use these antennas tied all the way down to the mission control area on the second floor. So this is just an overall of what the ARB Balloon Center comprises of. Okay, so you have the bay room, the bays, the ISO 6 clean rooms, you have thermal vacuum chamber, an anechoic chamber, a radio frequency testing rooms, mission operation centers, the antenna platform on the roof, and you have the biopsy table on the first floor. All of that can be used by one instrument or several instruments. Whichever way, whatever you need testing, that's what's available at this ARB building. So here's a view of what an instrument will look like inside the vacuum chamber. The instrument all the way at the top, that's actually Gusto. So if any of you are familiar with Gusto, that's just the payload. The payload is roughly 6 foot by 6 foot by 18 foot. And that fits inside the thermal vacuum chamber. You can see the scale of what the size is. Here's what it looks like just from the side view. There's Gusto. We have a trolley that goes into the vacuum chamber also that you can use. Okay, and it has a 10,000 pound capacity. That's what Gusto looks inside the vacuum chamber. So you can see how big this chamber actually is. One comparison that we told people so they can get a better idea is you can put a full-size Chevy Suburban, all right, or a Ford Escalade or Explorer, and it fits in there. And you have plenty of room to open the doors and not hit the sides. So that's what it looks like if you're looking at it with a door from the front. It's just for scale comparisons and to show that we have a lot of space, a lot of things can fit in here, including the entire payload for a satellite or a balloon system. Okay, so I'll take questions for now. Yes? Okay, so what we have to do is we have to make a schedule with the team that comes in here with a test instrument. They're going to tell us we're going to run we want to run tests for a cold cycle, maybe a hot cycle, cold cycle, hot cycle that takes maybe 8 hours each. So we're going to be in there for about 2 days. So we have to plan for a rotation of employees to be there around the clock and monitor the system. But before that happens in the thermal vacuum chamber, we also have to prepare. So we have to be in the high bay for about a week, assembling this instrument, then going through the process of the thermal vacuum chamber, removing it again from the vacuum chamber all outside and dismantling it. So there's probably another week there. It could be anywhere from a week to, let's say, 3 months. And we have to have people there monitoring it the whole entire time. Okay. Those people are great. We don't know yet. I actually have a meeting with Jeff Kingsley this Thursday, and we're going to talk about people. Because we need people to run this chamber, but we need people that know about cryostats. We need people that know cryogenics. We need people that know vacuum. And I do have some people that we have talked about, and I have talked to some of them. They are interested in this, but I have to go through Jeff Kingsley, and we have to see how we're going to do this. Okay, so We don't know yet. We'll find out more coming this week when I go talk to Jeff Kingsley. Yes? Oh, the cold, it can go, oh, the cost for running. Oh, okay. As to be determined. I'm talking to, because Tim Swindle and I have been looking into this for the last 2 or 3 months. And we have some estimates, but we have to run a test cycles before we can actually set something concrete. We have some ideas, but we want to be competitive, let's put it that way, okay? We don't want to price ourselves so high that we'll never have anything, but we also don't want to be so low that we give it away. We are not covering our costs. So there is a cost going on right now, and Tim Swindle is leading that. So I'm not exactly sure what the cost is going to be. Okay? Any more questions? Okay, thank you.